Today we're going to take a look at Introduction to Algebra. So it's important that you understand some key terminology first. So the first definition that you need to know is that a letter used to represent an unknown we refer to as a variable. Algebra refers to expressions or equations involving variables and numbers. So a combination of letters and numbers is what we refer to as algebra. You're going to need to know the value or to know the definition of the word term because we're going to use term when we look at a lot of our expressions in algebra as we continue throughout this unit. So a term is a single number, a variable, or numbers and variables multiplied together. So for example, it could just be the number 9, it could just be the letter x, or when we have a number right in front of a letter like 5x or 7y or even 8xy, those represent that those terms are going to be multiplied together. We can even have terms that involve exponents like 5x squared as well. When we're looking at a term, the coefficient is the numerical term in the value. So the number in the term we refer to as a coefficient. And the last definition that you need to know is that a constant is just a term that involves a number. So there are no letters attached to that term. So if we were to look up at our examples up here, 9 would be an example of a constant because it just has a number. So there's no letter in that term. So if I wanted to know what the coefficient of each of these terms are in this next set of examples, I need to identify my number. So 14 would be my term for the first one. I'm going to keep my negative sign with negative 15. So negative 15 is the number in negative 15ab. If I'm looking at 5x squared, 5 is my coefficient, that's my number. And if there is no number shown, we use the imaginary number 1 as our coefficient for that term. If I want to look at the next example and I want to determine the constant term in each expression, I want to look at the term in my expression or my term in my equation that just includes the 2 or just includes the number. So it's a 2 in this first example. My number in the second one is negative 7. I include the sign that's in front of my number. In 10x squared minus 3, my minus 3 is my constant term. And in 5x, there is no constant term, so I can write 0. Sometimes you'll see algebra tiles used to help visually represent an x or even an x squared. And these are very helpful for those of us who are visual learners and for those of us who are looking at algebra for the first time. So if we want to use the concept of algebra tiles, we use a little square to represent a number, so to represent a constant. So each little square represents 1. We use a rectangle to express the letter x, and we use a large square to represent x squared. And we use a generic rectangle x that can't be replaced with a certain or a whole number of constants. So you will notice down here in this example, our x tile is slightly longer than 3 constants or 3 numbers, but it's a little bit shorter than it would there before. So you'll notice that your number ones can't create either an x or an x squared. When we're looking at representing algebra tiles or expressions using algebra tiles, sometimes you will have dual colored algebra tiles. But for our questions, in the worksheets, we're going to use white numbers or white squares to represent positive tiles, and we're going to use gray or shaded squares to represent our negative tiles. If you're using an app that uses negative and positive algebra tiles, they could be different colors, but for our worksheets, the clear ones will be positive and the shaded ones will be negative. And so we can have both positive x squareds, x's, and 1's, as well as negatives, x squareds, x's, and negative 1's. And so we can use these algebra tiles to help us represent graphically what our expressions are going to be. And this is helpful for some, again, those students who are visual learners, and for those who are first looking at algebra for the first time. So if I wanted to represent -2 graphically, so using algebra tiles, I would draw 2 little squares. And I would shade them in because these are because they are negatives. So I'm going to try these again. So I have one square that's shaded in, and I have a second little square that's shaded in. Okay. The next example is 4x. So if I have 4 x's, I have 4 rectangles. These are positives, so I don't need to shade these in, and I'm going to draw 4 of them. And those would be my 4 x's. If you wanted to write in your letters, you can, or you can just keep your rectangles. That's fine as well. For my next example, I have -3x. So this time again, I'm drawing my rectangles, but because they're negative, I'm going to shade them in. So I have 1 negative rectangle, I have 2 negative rectangles, and 3 negative rectangles to represent -3x. The next example is -3x squared. Because I have x squares, I'm going to draw large rectangle or large squares, and I'm going to shade them in because they're negative. So I have 1 negative x squared, 2 negative x squared, and 3 negative x squared. So -3x squared can be represented with 3 large squares shaded in. We can also use algebra tiles to represent expressions. So using one or more terms separated by addition or subtraction signs. So if I have x squared, I have a large square. It's positive, so I don't need to shade it in. And I have -2x. So I have 2 rectangles that are shaded in to represent that they are negatives. So x squared, take away 2x. Okay. For my next one, I have -2x squared. So I have 2 large squares shaded in. Those are my x squareds, and those are negatives. And I have 3 little squares, and these are positive, so I don't need to shade those in. So -2x squared plus 3. And lastly, I have x squared. It's positive, so I'm not coloring in my large square. I have 2x. Those are positive again. So I'm going to draw 2 rectangles that are not shaded in. And lastly, -2. So I have 2 small squares that are shaded in. So x squared plus 2x, take away 2. So using the algebra tiles, I can visually represent my expressions using a concrete method.